your enter screen అంటే వాళ్ళకి
స్టార్ట్ చేయాలా? Good morning. Class 3. Today we are going to concentrate on friction and its application. You know, when we are moving on a road with a shoe or a chappal, because of friction only, we are in a position to walk on the road. Then, like that, even whatever the vehicle systems are moving on a different road, that is a rigid road or a track, these all are working based on the friction. But some cases, few cases, we will make sometimes assumption without friction we can try to solve the problem. But what is the friction and its applications? So we'll try to discuss today, and we'll after that we are going to solve some problems and what is the methodology. So this is the syllabus as for civil and mechanical. Both cases it is there in the syllabus. In civil it is specifically mentioned friction and its application. Mechanical it is inbuilt. That means different. You didn't mention, but when you are considering a mechanical system, friction is mandatory. That's why, but both the students is very useful. Lightly. Now let us see what are the today outcomes. What you are going to get, learning outcomes. We have to represent a system with a 2D or a 3D equilibrium equation by considering the concept of friction. Yesterday without friction we have considered, today with friction. And what are the specific applications? And here the friction concepts, some of the concepts, like sometimes we are considering a static friction or a dynamic friction. In dynamic friction again, sliding friction, rolling friction, and fluid friction, like that. The friction can be classified, these all we will discuss in detail. Explain the relation between sum of forces and moment. The same thing what we have done yesterday, that part is not changing, that is same. Whatever the force we are going to incorporate, whatever the moment we are going to incorporate, the basic analogy or a philosophy or a basic equation don't change. You apply these concepts to physical systems, any system you take, mechanical or electrical or electronics or civil, any system you can consider. You have to understand the concepts. Once you understand the concept, you can solve any problem. Whatever the form, the twisting is given, you can easily understand. If you don't have concept, then the problem will arise. You have to update the knowledge as per the need of the society and as per the need of the examinations. The preparation of examinations, you have to, concepts are same, but you have to use knowledge in the different ways. But in a physical system, you have to apply in the different technique. That is the only thing. Okay. So these are the learning outcomes. So what you are going to get from today's class: equilibrium equations with friction. That is what is the meaning. Now let us start with the friction, which is nothing but opposes the moment. A tendency of a movement is called a frictional force, or simply a friction. It is opposite to the motion of a body. When you want to move in one direction, there is a resting force acting. When a locomotive is moving, aerodynamic force is a resting force. Automobile is moving, the aerodynamic is a resisting force. When aircraft is lifting, drag force, lift force, etc. Similarly, when the ship is moving underwater, there is a resisting force. Sometimes there is a direct contact between the two surfaces. Definitely, there is some amount of friction. There are the cases where we neglect the friction zero for a smooth surfaces like ceramic tiles, granite, like that. Any surface which is in a smooth form, we will generally consider the friction zero. There is also an assumption on it. But most of the cases, some amount of friction, that is what is the rough surface. A lot of if you see the roughness of the surface, lot of in between the two surfaces, lot of interlockings are taking place. Because of that, friction is always there. Or in other words, it is due to the some resistance to motion offered by minutely projecting particles at the contact surface. Those particles having different roughness. You know very well the particle is having no dimensions. And these are atoms, molecules, electrons, and other things. However, there is a limit beyond which the magnitude of force cannot increase. Okay? Or indirectly, in other words, we can define the resistance offered by the surfaces that are in contact with each other when they move over each other. That is what is the definition of the friction. We can represent in any form. There is some amount of resistance. Suppose when I want to pull your body, you will apply some resisting force. If I want to lift your body with your head, you will try to resist. That is what is called the resisting force. The resistance offered by the surfaces that are in contact with each other. But it is a contact between the two bodies. That is where the friction will take place. If suppose the applied force is more than this limit, there will be a movement of one body over the other. This limiting value is called the frictional force. When the motion is impending, starts to slide, and it is known as a limiting friction. Under static condition, we will call it a static friction, but as you go on, try to move, there is a motion try to impending, that is known as the limiting friction. When the applied force is less than the limiting friction, the body remains at rest. That's what I am saying, static condition. And such a frictional force is called the static friction. And now let us come to what is the mathematical analogy, how generally we will represent it. If you can see a body, there is a block which is resting on a rough surface. Because the rough surface means between the number of particles are touching, a lot of interlockings between the two things are taking place. This is what is the surface which is interlocking between the two surfaces are taking place. Then these are the external forces, that is the P, and this is the weight of a body W. And this is what is called the active force and reactive force you have to apply. This is the reactive force, and these are the active forces, and the frictional force. There are four forces are active. The frictional force is generally defined as a coefficient of friction in terms of coefficient of the friction between the two surfaces. Let us mu is the coefficient of friction, the notation. Mu, coefficient of friction is denoted by mu. Then it is defined as the ratio of the frictional force divided by normal reaction. Or in other words, the frictional force is equal to mu times normal reaction. See, that is what is called the standard equation of the friction. So now here the free body diagram, this body, if you can remove from the surroundings, consists of, let us assume that this rough surface I am removed, I applied the two forces. Okay. Upward force is equal to downward force. W is equal to N and P is equal to mu N. That's all. These are the two equations here. Or from these two you can determine the resultant, because these two are perpendicular. The resultant and this force, then three systems are concurrent, three forces are concurrent, must and should be equally. Draw a polygon or draw a geometric like Lami's theorem or analytical methods. Apply some of the force x direction 0, some of the force y direction 0. See, this is how generally we'll try to define the concept of the friction. The friction is defined. This is the standard definition of the friction. Here the one term which we are introducing, that is what is called the coefficient of friction, that is mu. Mu is equal to F by N. That is the frictional force divided by the normal reaction. Some textbooks N can be represented as R, some textbooks even italic, that is the Greek terms eta. There are so many notations, but whatever may be that, it is a ratio of the tangential force between the two surfaces, the resisting force, otherwise, divided by the normal reaction. The reaction, what is the notation, you can define. But most of the people mu, coefficient of friction will represent as a mu, either in a straight form or in italic. What are the types of friction now? There are four types of friction, namely, which I already mentioned: static friction, sliding friction, rolling friction, and fluid friction. Four types of this is a standard classification. All four are in the different nature. There is a lot of difference between each one. Static friction I already applied, already mentioned that. It is almost in the static condition. Skiing against the snow, creating heat by rubbing both the hands together, that is also friction. That is static friction. Table lamp resting on the table. Like this you can quote number of examples, friction examples, or in applications. So these all are called the static frictions. There is no question of dynamic nature. Then coefficient of static friction. Just now previously defined. The maximum force of static friction is given as product of coefficient of static friction into normal force. That means static friction is less than or equal to the product of coefficient of static friction and normal force. See, the minimum to maximum, if you take, maximum is equal and minimum is less than that. That's what it means. See, the frictional force is always, static frictional force is always less than or equal to coefficient of static friction into normal reaction. Then only we call it the static friction, otherwise it is not the static friction. So this is what is the analogy. That is the maximum amount is this value. This is the maximum. We cannot exceed. It is equal to this value. Or less than. Nothing will be happening. But it should not be more than this. Then it is called non-static. It will come with the other types of force. So that's why this is sometimes asking in the gate examination. What is the condition of what is the maximum value of the static friction? Or what is the range of the value of the static friction? This is the range. Less than or equal. Okay, from the gate point of view, sometimes the objective nature or a competitive examination, they will ask this question frequently. Now, if you can see the schematic representation, static means there is no motion, left side. This is the static friction. There is no question of any impending motion here. That's what. But the same philosophy, if there is a motion sliding, then it is called the sliding friction. If it is a rolling, like a cube and a cylinder, we can keep here simple three-dimensional object cube and three-dimensional object cylinder. If you can keep, this is a sliding or this is a rolling. Because the degree of freedom is also most of times our case either sliding or rotation. That is a translation or a rotation. The same philosophy we here also happening. When there is a rolling surface, there is a friction. When there is a sliding surface, there is a friction. Like piston and cylinder is a sliding. Crankshaft is a rotation, rolling. That is at the one end. What are the factors generally affecting the friction? The value, why it is changing? The mainly two factors are, one is on the nature of the two surfaces that are in contact. That's which I already mentioned, smooth or rough, semi-finish or finish. Then what? Different classification is there, smooth surface means. Similarly, rough also, medium, very high roughness, low. Like that you can vary, but generally we will classify as smooth or rough surface. And the nature of the, when I am rubbing the two surfaces, some hands are very smooth, some hands are in rough nature. In that case, we will call it the persons who are working in the field, their hand, if you can see, a lot of roughness is there. See, that is how the smooth and rough surface, like that you can give number of examples. And another important factor which is affecting what on the force that is acting on this surface, that is the frictional force, times the normal reaction, because between smooth and rough there is a normal reaction. The force that is acting on these surfaces, it is a function of the normal reaction. So that's why these two are a little bit interrelated parameters. So this is how generally we consider the factors which are affecting the friction. Now, dynamic or kinetic friction sometimes. Just now previously I had given a 4 classification like static, sliding, rolling and pulling. The dynamic or kinetic friction is less than the static friction, limiting friction. It is limiting is nothing but that is what is less than or equal. And this value is less than that. Here the sliding motion and the rolling, so sliding friction and rolling friction, when a force is applied, exceeds the limiting friction. The body starts moving over the other body and the frictional force resistance experienced by the body while moving is known as a dynamic. That's why, because it is a dynamic condition, not a static condition. The body already in dynamic nature. That type of friction is generally classified into 2 types, sliding and rolling. Sliding friction is the friction experienced by body when it slides over the other body. Previously on the figure I already explained. Similarly, rolling friction is the friction experienced by a body when it is rolls over the two surfaces. These are the 2 things, sliding concept and rolling concept. Experimentally, you can find that the magnitude of the limiting friction is the ratio of the normal force, that is the normal reaction between the 2 surfaces and the tangential force. That is ratio of the tangent force divided by normal reaction is called the coefficient of friction. This is already defined, but in each case, sliding case we have to define one value, rolling case we have to define another value. See, like that, these, but out of the 4 which I explained, these 2 important parameters we are considering the dynamic or kinetic friction. Because dynamic energy is nothing but kinematics and kinetics. Here, friction is talking with respect to force. That's why we are not considering the kinematic, only the kinetic. That is what the meaning of dynamic or kinetic friction. Following are the, now let us come to each case, what are the examples, applications otherwise. Sliding friction already defined previously, I hope you got the concept. 2 objects which are sliding on between the 2 surfaces and rough nature. The sliding of the block across the floor. 2 cords sliding against each other in a deck. When I move as one block on a floor, moving machinery on surface, These all are on a flat surface. Any rectangular shaped block. But if it is a cylindrical block, we can try to roll it. That is the easier method. That also, if you want, you can slide it, but that is not that much stable. Rolling is always better. Here, the coefficient of friction is sliding friction is defined as mu s, which is actually mu s into f normal. So the coefficient of sliding friction is not mu r, mu s, mu suffix s. That means sliding friction. See, there is a difference between the static and sliding. Don't confuse with that. So the static is different, the sliding friction is different. This is mu r into, here I see normal reaction is represented Fn. Like that, the different people will use different notation. Either N or R or Fn, sometimes Greek letter eta also will represent. That is your choice, how you are representing the normal force. Now, see the rolling friction now. That means the force which resists the motion of a ball or a wheel, and it is the weakest types of the friction because it is a line contact. Rolling means it is a line contact. Earlier it is a surface contact. See, that's why there is a difference between the sliding and rolling. Rolling contact and sliding contact. The examples are rolling of the log on the ground, wheels of the moving vehicles. It may be automobile, or it may be locomotive, or it may be an aircraft, or it may be sometime whatever the guiding mechanism, rolling concept which we are using. The coefficient of rolling friction is denoted as mu r. It is actually here the small change in the notation, mu r, not mu s. Previously, this is the expression again. Rolling friction is defined as again a coefficient of friction into the normal reaction. Then the last one is fluid friction. This is not common to the. This is one type of friction, but as far as our subject is concerned, we are talking about rigid bodies. We are not talking about deformable or flexible bodies. This parameter we are not considering. But when we are considering multi-physics systems, like the interaction between the solids and liquids, like a ship moving in a water, aircraft moving in air, in that case we have to consider this type of friction, fluid friction. Okay. The examples are flow of ink in pens, how when we are writing something, how the ink is coming. That is again due to friction. Swimming, ship is moving on the water. Like that, you can mention number of cases, fluid friction examples. What are the other examples? Friction finds in application when matchsticks are ignited. That is again due to friction. In olden days, by rubbing stones, we are getting ignition. That is the best example of the concept of friction. So similarly, nowadays we are using matchsticks to get a fire or ignited. Motion of the piston in a cylinder in an application of friction. It is possible to write on books and board as there is a friction between the pen and board, or there is a friction between the chalk piece and the board. When you are arranging also, there is a friction between the duster and board. See, these all are, wherever you are working, always this concept will come into the picture. Like that, you can specify n number of applications of it. Any surface which is we are keeping, we want to slide or if you want to rotate, these friction concepts are coming into the picture. Whether it may be a rigid body or whether it may be a deformable body. See, these are called that means what we have covered till now is what is friction, how it is represented, that is one part. Second is, what are the types of frictions? Generally we come across, there are 4 types. Static, dynamic. In the dynamic, we have a sliding as well as rolling because it is in a motion. Sliding or rolling. The last one is a fluid friction. And applications. What are applications? You can specify n number of applications. If a system is having without friction means there is an assumption like rigid body. It is an assumption only. In the universe, there is no question of rigid body. Even I am holding a chalk piece, if you can see under microscope, there are deformations. But compare with, suppose I am holding my hand with this, like this. With a naked eye, it is visible. This we cannot neglect. But in the chalk piece, the deformations are there, but it is negligible. That's why I am assuming. That is, if it is a valid assumption, we can start with those assumptions. Otherwise, what is happening? If you don't make any assumptions, if you include all the things into consideration, then formulation of problem is difficult. It will be cumbersome. We cannot get the equation. Nonlinearity will come into the picture. Again, nonlinearity, what is the order of nonlinearity? See, because of that, in the UG level courses, generally we will neglect the higher order terms. And we will make some assumptions while we will neglect other things. We try to simplify the problem and make formulation of equations solve. See, these are some of the things where we have to, in that case, these are useful. See, now with this, let us start with what are the laws of friction. There are some 6 laws basically which we are using. The force of friction is always acts in a direction opposite to that which body tends to move. That is the first which is already defined. That is the basic principle. But another important point is, till the limiting value is reached, the magnitude of friction is exactly equal to the force which tends to move in the body. Until limiting value, the magnitude of friction is equal to the force which tends to move the body. The magnitude of this limiting friction bears a constant ratio normal reaction between the two surfaces of contact, and the ratio of the core and the normal reaction is called the, that is force by ratio. Normal reaction is called the coefficient of friction. The force of friction depends upon the roughness, smoothness of the surfaces. Already these all are defined, but in terms of laws, sometimes what are the following are the laws of friction, you will give A, B, C, D. In that you may mention 3 of above, 1 is all above or none of above, like that sometimes they will ask us. See, in that case you have to be familiar with all this very carefully. The force of friction is independent of the area of contact between the two surfaces. Whatever the type of independent of the area of contact. Earlier we mentioned sliding or rolling, but area is there, one is the surface and another is line contact. But because of that, the value is changing directly, but it is mathematically it is not depending. F is equal to mu times n. Mu is a coefficient of friction, n is a normal reaction. There is no question of area here. That is what is the meaning. But directly it depends upon the value is changing. Mu is changing with respect to what type of surface here is. That is but not mathematically it does not depend. Then the last analogy is, last principle is, law is, after the body starts moving, the dynamic friction comes into play. That's what. Static becomes a dynamic once it is impending motion that starts to move. This magnitude always less than the static friction. And it bears that, again the ratio is same, force by the normal reaction. That is what we are calling here the coefficient of friction. Okay. These are the 6 laws. Generally, we will use whatever we discussed earlier, all are consolidated, and we are representing as laws of friction. Now, let us take a simple example. One is the block, this is the block. I am considering a 2D problem, let us. If it is a 3-dimensional, 3D problem. Here I am considering a 2D problem. One is a block resting on plane surface, another is the same block resting on inclined surface, which is making an angle theta. That's all. What is the difference? Here, Fn is a vertical force, weight is downwards. Your normal force, reaction force is equal to W. This is equal to this. This is the normal force, reaction force. This is the weight of a body, given weight. This is the active force and this is the reactive force. Because only if there is no friction, both are equal. Upward force is equal to downward force, Fn is equal to M. See, that is what is the meaning of it is a static condition. That means there is no frictional force. There is no horizontal force basically. If it starts to moving, then it will come into the frictional force, the static nature or dynamic nature, in terms of the normal reaction. Then, whereas here in this case, this is Fn, weight is acting downwards, because the angle between the two is theta. This one, vertical axis downwards, vertical axis is perpendicular to this. This line is perpendicular to the inclined surface, that is the angle between two is also theta. This is the weight, W cos theta, and along the inclined plane, W sin theta. That means this W cos theta is equal to the weight acting. That W means mg cos theta is equal to force. So this is how generally we will try to represent, if there is a frictional force, that frictional force, suppose small angles of theta, the block always in the rest condition, like a static nature. If you increase the angle, then it starts sliding. Then the frictional force comes into the place. If sliding, frictional force is upwards, because W is downwards here. When W is downwards, this is W cos theta and this is W sin theta. That W sin theta, frictional, when it starts sliding downwards, frictional force is acting upwards. See, that's why one equation is upward force, that is along the plane, and another is perpendicular to the plane. Along that plane, normal force is equal to this W cos theta, mg cos theta. And along the plane is mg sin theta. Mg sin theta is the frictional force, Fs. So this is how we will try to represent the frictional force, the normal reaction, mg or mg cos theta. That is how the difference between, as theta is changing, see how the normal reaction is changing. When theta is 0, same condition will say that both are same. When theta is varying, it will go to the maximum, or let us say 90 degrees. Cos 0 is 1. Cos 90. Like that we will, there almost no effect, 0 normal reaction. So this is how generally we will try to analyze the different types of systems. Now let us see the other examples. How to, first and foremost point is you have to draw a free body diagram. Earlier I given a block, this block. I have not applied external force, only weight is acting. The weight is acting. I have not applied any external forces, only weight is considered block. And this is the reactive force. That reactive force is normal reaction is equal to weight, that is mg. There is no external force. But in this problem, I applied the external force by making an angle theta. Weight is also considered, W. And this is the frictional force, because due to application of this force, the block tends to move in this direction, the frictional force is always acting in the opposite direction. That is F is equal to mu times the normal reaction. Now if you draw the free body diagram, you apply active force, reactive forces. Active is F and weight of the block. The weight is mg, active is, I am resolving two components, f cos theta, f sin theta, f cos theta, f sin theta. Then normal reaction and frictional force. We have four forces. The resolution of this force, because the theta is given, let us assume these two are known quantities, frictional force. Like that we can determine. Now the vertical force, some of the vertical force 0, some of the horizontal force 0. Some of the vertical force are, this is 1, this is second, this is third. This is downward, f sin theta plus mg, when this is upward is equal to n. That's all, simple. Whereas the horizontal is, this f cos theta is equal to this force. Both are opposite. See, that is the horizontal. To depend upon the input data, we have two equations, two unknowns, you find out. Because here there is no question of perpendicular distance. Because this force, three forces, this is one, this is second, reaction third. Three forces is a concurrent type of system, it will intersect at one point. That's why there is no certainty of the moment equation here. Okay? Now, let us go to the other problem. Here two blocks, one is touching on the inclined plane, another is freely flowing with respect to an pulley. That means, if you neglect this effect because the same tension is acting like this, if I can neglect other forces, rolling friction and other things, sliding friction or a belt friction or a rope friction, these are the different applications. If I can neglect that, I am considering only the other, these are the two things. Let us say the weights are given, angles are given, inclined angle. I am considering forces along the plane and perpendicular plane. That is what the meaning of along the plane and perpendicular to the plane. This is the tension in the string. This is the normal reaction. If the block tends to move downward direction, the friction, because this block tends to move in this direction, frictional force is opposite. This is what is the frictional force. If blocks tend to move upward direction, this tends to move downwards, frictional force is acting upwards. See, that is how we have to decide, depend upon what condition. By static condition, you resolve the forces. If resultant force is acting in a positive direction, that is downwards, it is, we can say that that is the direction of motion. Otherwise, it is the opposite to that. That is how you have to make a resolution. Okay. Now here I am assuming that it is moving downwards, and with this moving downward means obviously it is moving upwards and frictional force is acting downwards. And tension in the string T. This is a reactive force. And weight M2G, MR mass small m, capital M, small m, capital Mg. Because if the angle between these two is alpha, angle for this line, for this surface, this is perpendicular. For this surface, this is perpendicular. That's why this angle is alpha, this is also alpha. And the normal reaction, there are four forces: frictional force, normal reaction, weight, and tension in the cable. Okay. Now this is from this only one equation. There is no horizontal forces. Tension is equal to mg. That you can substitute here. Small mg, and it is capital Mg. Mg can be resolved as mg cos alpha and mg sin alpha. Frictional force is mu times mg cos alpha. Because normal reaction is along this mg cos alpha. Okay. If you can resolve the forces, n is equal to mg cos alpha. Normal reaction is mg cos alpha. And frictional force is equal to T. Frictional force is nothing but mu times normal reaction. That is mu mg cos alpha. See, that is how we will try it. If there is no friction, Fr is 0. There is no horizontal, only T is equal to mg sin alpha. But here in this case, the total vertical equation is n is equal to mg cos alpha. Horizontal is F for frictional force, m2g sin alpha the two components in this direction, tension in the opposite direction. Now the tension can be determined by T is equal to Fr plus mg sin r. Now substitute the given data and obtain the amounts. That is simple. See, once your free body diagram is clear, this is how the gate examination. Don't waste much of your time. Simply represent free body diagram correctly. Once the free body diagram is correct, there is no question of doing any mistakes. Only the latter part is writing equation and substitution of data. But only thing is, when you are drawing a free body diagram, what are the active forces and what are the reactive forces you try to represent. That is the only thing what we have to do. I hope you got some clarity. And if you like that, you can take any number of cases. Like here in a friction, we will consider wedge friction, screw friction, belt friction, different applications of mechanical engineering as well as civil engineering. These are some of the components which we are frequently using in mechanical and civil systems. See, now let us come to the similar example what I have done previously, but here what I am doing is I am considering the pulley also, M2. The M2 is a pulley weight. This also earlier weight is negligible and there is no reaction force. So now it's otherwise the problem is same as the previous problem. See, now what we have to do is draw a free body, remove all surroundings, constraints otherwise. M3 is resting on inclined plane, M2 weight of the pulley is given, it is a fixed pulley. In the pulley, because this is the support, there is a normal reaction. The gravity force, because M2 G. This tension is T3, actually parallel to this T3, like this. The direction is not horizontal, the direction is parallel to this. The direction is parallel to this. Like that rotation. Suppose if there is a flat, there is no inclined plane, the block is something like this. Then the tension is like that. But that generally don't consider that type of case. Horizontal surface, if you want, we can keep, in that case the tension is T3. Like suppose if you are considering previously, here, if I connect a pulley weight downwards, then the tension is horizontal. Here tension is parallel to this. Active force and reactive force. See, that is the reason why this tension is something like parallel to this. So now see, this is what is the normal reactive force, gravity force. Earlier it is negligible, it is neglected because no friction, these two are equal. That is an assumption. But here, if these are the parameters you are considering, obviously these two are not equal. You have to modify. Okay. So now same thing earlier, T3 tension in the string, the normal reaction, Fg, that is the weight, gravity weight, normal reaction is upwards, weight is downwards. This weight you resolve vertical component and horizontal component, Fg3 cos theta, Fg3 sin theta. And this is the frictional force, because the block, I am assuming they are moving downwards, because of the pulley is rotating clockwise, and this tends to move upwards. Now we can write the two equations of motion for each body. Here are two equations, along the plane and perpendicular to the plane. Here also we can write with this as a center, horizontal forces and vertical forces. And here only vertical, there is no horizontal. Now write the equations, try to solve and get the unknowns. If it is a static, if it is a dynamic, the net forces is equal to mass into acceleration along the plane, mass into acceleration in the perpendicular to the plane. And then the dynamic, in the dynamic case, if you are considering a friction, this will come into the picture. When we are discussing dynamics, we will try to discuss in detail, but in the static condition, that MA is 0 because it is either state of rest or maybe motion which is a uniform velocity, uniform motion, constant velocity. Here, if you can see, there is nothing wrong. Here I am taking along the plane, perpendicular plane. Here I am taking parallel to the reference base frame, and here also I am considering. That's why this is your choice. Once you represent the free body diagram, you remove. But here also, if you want, you can consider like this, parallel to this and perpendicular. Or you can consider parallel to the along the plane and the perpendicular to the plane. Okay. So this is how generally we try to represent the analogy. Depend upon the static problems and depend upon the dynamics. In the dynamics only, the sum of the force in a particular direction is equal to mass into acceleration. That is how we will try to consider the problem. Now let us consider the different cases. See, there is here generally there is no formula for like something like how to calculate normal force. It depends upon the situation. What type of situation which can be considered? Its magnitude depends on the situation. Okay. Hold up with suppose a 4 Newton force is applied upwards, weight is 10 Newtons downwards. The weight of this block. I applied a external forces is 4 Newtons. Weight is downwards. This block 10 Newtons. Weight always same. 10 Newtons, 10 Newtons, 10 Newtons. But the only thing what I am doing is the force upwards, downwards, and instead of surface here, the surface we put here. What is the difference? This because the weight, self weight is acting. If a human body is header is put fix it to the rooftop, some hook. This situation will, this is the situation. That is what the weight due to self weight. That is let us say 10 Newtons. Now if you can see the normal reaction, if one force acting upwards, weight is acting downwards, obviously the normal reaction is less. If force is applying downwards, already weight is there, total together, it is a 14 Newtons. Because upward force is equal to downward in the second case. In the third case, both are this with no difference. Whatever 10 plus 4 instead of 5 plus 10. So this is the analogy which we will apply in real life of the problems. Now see the another analogy, similar analogy. For an object sitting on a flat surface, the normal force is just its weight. Upward force is reaction N and downward force is weight. Weight is equal to mg. If a force acts downwards on the object, the normal force is greater than the weight. Here. The force acts downwards. And in addition to that, this is the external force. In that case, what is happening is normal force is greater than the weight. Because this is the weight plus F sin theta. Obviously, it is more than. Earlier, same. Now it is, when you are applying external force, that effect is also coming to the picture. If a force pulls upwards, like this, the normal force is less than the weight, minus C. If you apply force like this, it is less than the weight. If you apply force like this, that is dependent upon theta. What theta? This is a clockwise and there is a counterclockwise like that. If you can consider, one is mg fg sin theta, this is f cos theta, and vertically is f sin theta. F sin theta plus n plus normal plus weight, both are acting downwards, normal reaction upwards. Okay, n is equal to mg f sin theta. Similarly, if you write the equation here n is equal to mg minus f sin theta. Okay, So this is how generally we will try to consider the problem. The same philosophy I explained here also. This is with the color block and the only other way. But if you see the inclined surface, the normal force is less than the, because cos theta. As theta, if we change 0 is 1, cos theta is 0 is 1. As any other angle, it is less than the, that's how mg, at theta is equal to 0, it is mg value, like this analogy. Otherwise, theta, if we change, it is less than that. That is what is less than the weight. This is one philosophy we are generally will try to come across. Now let us come to the next concept, is the angle of friction. The same figure I have earlier also explained, consider in this shown in the figure, resting on a horizontal surface subjected to applied force P. Let F is the frictional force, N is the normal reaction, W is the weight acting. Then angle of friction is generally called as, because this is the, as per Pythagoras theorem, F and N are perpendicular. If you have a resultant here, that resultant is making an angle with some angle. Tan theta is equal to, this is with respect to vertical. If I write tan theta, this is the resultant force direction. If this is theta, tan theta is equal to frictional force divided by normal reaction. Opposite side by its inside. So that is what is called tan theta by N. This angle is called the angle, the angle theta is called the angle of friction. As you increase the P value, that is external force, F is also increases, hence theta is also increases. If F is increasing, this is also increases. Theta can reach a maximum value, let us say alpha, when F reaches a limiting value. Then it is converted to tan angle. At this stage, instead of tan theta is called tan alpha. That is the maximum angle is equal to F by N is equal to alpha is called the angle of limiting friction. This is another important term. The definition which we are reading, hence the angle of limited friction may be defined as the angle between the resultant reaction and the normal to the plane on which the motion of the body impending starts to impending the motion. Then in that case, mu is equal to F by N, because tan alpha is equal to tan theta, theta is equal to alpha, and F is equal to mu 1. This is how generally we will try to represent the equation. Now next is, let us consider a block which is an inclined surface. N is a vertically upward because it starts sliding and the reaction force acting is upwards. Now sometimes we have to calculate the angle of repose. Here consider a block inclined when being angle of theta. When theta is small, the block will rest on a plane. While theta is gradually increased, theta is here written, theta is gradually increased, the stage is reached on which block starts sliding down the plane, moving down. Frictional force acting up. The angle theta of which the motion starts impending is called the angle of repose. So the maximum inclination of the plane on which the body free from external forces can repose is called the angle of repose. That is the definition. Once again I am repeating, the maximum inclination of the plane on which the body free from external forces can repose is called the angle of repose. If you resolve the forces vertically, weight downwards, that can be W cos, this is theta, because this is perpendicular to this, this is perpendicular, this is perpendicular. The angle between these two is theta, this angle is theta. See then, the weight, let us say weight downwards, this is the downward, W cos theta, W sin theta. W cos theta along, if you can resolve the forces, W cos theta is equal to M. This is one equation. This is the frictional force F and W sin theta, the second equation. You divide one over the other, F by N is equal to tan theta. W will be cancelled. If phi is the value of the theta, limiting value, starts motion, impending, that frictional is called the limiting value friction, that is tan phi. You know tan phi is equal to tan alpha, phi is equal to alpha, alpha is equal to tan alpha is equal to phi is equal. This is how generally the value of the angle of repose can be determined. Okay. This is another important parameter which are required to specify. Now the cone friction. Sometimes in the gate examination, this is also a question is asking what is the cone friction is. This I already explained the system. Weight acting downwards of this block. Horizontal force is applied. The frictional force is acting opposite to that. Then the resultant of these two. Suppose this is F, this is N. If you draw a parallelogram or a triangle, this is the resultant force. That's why they apply the between these two. That means this F is put here. Normal reaction you can put here. The joining of this is the resultant force. When the body is having impending motion in the direction of force, the frictional force will be the limiting friction, and the resultant reaction R will make an angle of alpha. If you can make 360 degrees rotation, the resultant R generates as a cone, right circular cone, which is semi-central angle equal to alpha. That is how that case we are calling as the analogy of cone friction is coming to that. It is form of a cone. That alpha, that resultant vector R with respect to horizontally make 360 degrees rotation on straight line, it will form a surface of a cone. That we are calling as the cone friction, the limiting value with alpha. Now let us, with this, the theoretical part is over. Now we'll try to solve some problems. You can understand because in the examination 50% weight is for theory, the remaining 50 for problems. I hope we almost completed 1 hour. Now let us concentrate the remaining part of our today's journey with some problems and some more pre-body diagrams. More problems I will discuss on concept of statics. 1 or 2 we will see in dynamics, but that in detail we will see dynamic later stage. Because at present we are touching only static part, engineering mechanics, rigid bodies and statics. Later we will see the dynamics. Okay. After completing 5 classes, today the 3rd class, 2 more classes I am going to touch the statics part. The remaining days we will try to spend in the dynamics part. Now we will note down the problem. Block A weighing 1000 newtons rests over a block B which weighs 2000 newtons as shown in the figure. That means block A is 1000 newtons, block B is 2000 newtons. Block A is tied to a wall with a horizontal string. Block A is tied to the wall with horizontal string. If the coefficient of friction between blocks A and B is 0.25 and between B and floor is 1/3, that is 0.3333. What should be the value of P? What should be the value of P to move the block B? To move the block B if the 2 cases. If the first one is P is horizontal, the second one is P acts at 30 degrees upwards to horizontal. P is horizontal, P acts at 30 degrees upwards to the horizontal. 30 degrees, that is inclined. I already mentioned previously, when P acts upwards with making theta, the reaction force is reduced. Tell the analogy. That's why depending on the situation, whether need a more reactive force or less reaction force, accordingly the P location, the P direction can be changed. That is the case here. Two cases are given. Now for every problem what we have to do is, we have to represent a force system by drawing a free body diagram. Draw a free body diagram and represent all the forces. Now we can see the right side. Here I removed all surroundings, and what are the forces are there? I represent it. Here, block A consists of a rope, that is a rope, string otherwise, because equal and opposite force. There is a tension T. Now, weight is acting downwards because 1000 newtons, 2000 newtons. Because when it starts sliding, moving towards B, it starts to move towards right, towards the right. That's why as far as this block is concerned, the frictional force is acting opposite to this. Opposite to this. That's what. When B is moving towards right, A is moving towards left. When A is moving towards left, opposite to that, the frictional force is acting. That is what is F1. Normal reaction is anyway always upwards. See, that is, we don't confuse here. With reference to this is moving. Let us assume it is moving right. At this point, with reference to this, the frictional force must act in this direction because block is moving in this direction. See, that's why the active and reactive, the two equal and opposite force. Here, frictional force. With reference to this block, with reference to this block, when block is moving towards right, it has to act towards left. Similarly, here also, when it is moving towards, it is acting left. Anyway, weight acting downwards, normal reaction upwards. This is the weight direction. And this is how generally we will try to consider. The free bar diagram 1 of block A and free bar diagram 2 of block B. Now apply the equation. Vertical force equal to 0, horizontal force equal to, if it is a static system. If it is a dynamic system, vertical force is equal to mass into acceleration in x direction, and horizontal vertical force mass into acceleration y direction. Horizontal force, sum of the force in horizontal is equal to mass into acceleration in x direction, or along the plane and perpendicular plane, or normal and tangential. What are the directions you are using? That is your choice. Okay, that is your option, your convenience. But you have done mistake in a free body diagram, your entire problem is wrong. Anybody can make sum of the forces. Positive axis positive, negative axis negative. Let us assume counterclockwise positive moment, clockwise negative. That there is no question of any big mistakes at all. The mistake is most of times in engineering mechanics, the mistakes will be happening by representing the free body diagram. That's what be careful about. Once this part is clear, then there is no question of further mistakes in the problem. That's why please spend more time on first what type of force system it is, what is the free body diagram. Once it is clear, the concepts, that is what I mentioned, learning outcomes. If you are clear with the concepts, then there is no question of doing any mistakes. If you don't have clarity in concepts, if you do mistakes in free body, then you don't get answers, the time waste, and somebody will occupy your check. Okay? Now let us come to the how to write equation. Now let us see the left side, sum of the vertical force, Fy0 or V0. You represent in any form. For F1 block A, this is what? Downward 1000 is equal to N1. Only two forces. T is equal to F1. Only two forces. Horizontal force T is equal to F1. Vertical force 1000 is equal to N2. That's what? 1000 is equal to Then F1 is a limiting one, F1 by N1. Find out mu N1, frictional force. N1 is this, 250. This is what is the vertical. The vertical is 1000 minus N1. T is the horizontal is T minus F1 is equal to 0. Or F1 minus T is equal to 0. Any form you can write. Right side is positive or left side is positive. That is your choice. But throughout the problem, you have to follow the same convention. In one case, right side is positive, in another report diagram, left is like that, we can't do. Throughout the problem, you have to follow one convention. Then F1 minus T is equal to 0. From this, T is equal to F1. F1 is equal to mu1. We already got mu value is given. Mu value is given as 0.25. 250 newtons. This is what is the block A. When you are applying block A, these are the equations. When you are applying horizontal force P, that is the case, horizontal force P. Second case is inclined force. Force is applied 30 degrees. That we are not solving till now. Only first we are applying this problem is done. We determined T as well as we determined N1. This is what the T and this is what the N. Now go to the block B in this situation. For block B, F1 is by this time a known quantity because it is already determined. N1 is also known quantity. This is N1 equal and opposite force. N1 is known quantity. Weight is known. Horizontal force P is horizontal. That we have determined. F2 and N2. N2 friction is given. Mu times normal reaction. This is how, that means normal reaction and P are unknowns. Two unknowns are there. Because F1 is known quantity. Here if you take two unknowns, N1 and T. F1 is equal to mu times N1. Two unknowns, two equations. Similarly, here also the system must and should consist of only two unknowns finally. F1 is mu times N1. By this time, we already done calculation of this. We know this quantity. N1 is known to you. This is known to you. Only unknowns are P and N2 because Ft is also mu times N2. Mu is given between 4 and 1 by 3. That is 0.33. See, that is the reason why N2 is one unknown, P is another unknown. Two unknowns. Now, some of the force in horizontal 0, some of the force in vertical 0. Here, this is what the vertical forces. Vertical forces are N1, N2, weight. N1 weight acting in the same direction, N2 is acting in opposite. That's why N1 plus 2000 is equal to N2. N1 plus, this N1 if you move, N1 plus 2000. This we move on the other side. This is plus. Or otherwise in one direction if you had right, what is the logic is? Upward positive, this is positive, these two are downwards, negative. N2 minus N1 minus 2000. In any form you can write, that is the choice is also. But the same equation only will get. By this time N1 is known to you, N2 is equal to N1 plus N2. That is 2000 plus 1000 newtons. Okay. See, sometimes the people are doing mistakes. When they are considering block, they will consider 1000 here. When they are considering this block, they will include this weight also. Because of gravity. That is not correct. Why? Because this body we are removing from all surroundings, applying active and reactive. Whatever the effect we already include. This effect is already considered here. See. And so you cannot add again, it is 1000 plus 2000, 3000. That is not correct. This is already considered. That effect is already came into the picture. N1. Indirectly is 3000, but from the analogy you have to bring. Otherwise you will do somewhere mistake. Because to calculate F1, we need mu times normal reaction. First find out N. Tension the K. Then come here. F1 is equal to mu times N1. Then go to the other unknown parameters. That convention you have to follow. Don't simply add like that. See, sigma vertical is equal to 0. Now N1, N2 we got. Friction, once you got the normal reaction, frictional force between the floor and the block B is equal to mu times normal reaction, or ratio of force by normal reaction is friction. This is given as an input. N is known, N2 known, this is known, then F2 is equal to 0.3 into 3000. This is how we will try to get the value. This is actually 0.3 into N2. N2 is 3000. There is a mistake here. Now let us come to the second case. The second case is when the P is making 30 degrees with the horizontal. That means the P is acting like this. The remaining all are same. The free body diagram is same. Only P is coming as some inclination with theta. The theta is 30 degrees. That's what I represented here. If you can see here, the first drawing is same, the second drawing entire thing is same. Only instead of P in this direction, you have to change. That is what is there. Here N2 mustn't should be, the value should be reduced. That we already done the philosophy. See, now let us see some of the vertical forces for block. The two, if we can combine here straight forward, nothing will change. The previous analogy valid until this. Earlier, whatever the N1 you got, same N1, 1000 newtons. Same F1, the same friction. Only the analogy will change with respect to block B. There is no difference in block A conditions or terms. For block B only, you have to write the vertical and horizontal. For block A, there is no change. You already got N1, you already got T. 250 Newton, 1000 Newtons. Those two you can use as an input. Now let us see the vertical forces. Here, N1, weight W, N2, three forces, active and reactive. And P is cos theta horizontal with vertical sin theta. See, that means normal reaction N1, weight acting downwards, and P cos theta, P sin theta acting upwards, N2 acting upwards. That will be total four forces. See. N2 upwards, positive, N1 downwards, negative, 2000 newtons downwards, negative, and P sin theta upwards, positive. From this, by this time N1 is known to you, substitute. N1 plus this 2000, this is what is the value. N2 plus P sin theta. Sin theta is 1 by 2, that is 0.5. From this N2 can be determined in terms of P. Now represent the equation like this now, because N2 is unknown, P is unknown. Now go to the second one, second equation. F2 is equal to mu times N2. N2 is this, mu times N2, F2. Now let us go to the horizontal. Horizontal is P cos theta and F2. And here F1 is also there. This F1 will be coming like this also. That's why three forces. P cos theta right side, left side F1 plus F. P cos theta minus F1 minus F2. If you move to right side, F1 plus F2. Here F1, F2, F1 with reference to this block is this similar force opposite acting here. If you represent that, now P cos theta is equal to F1 is 250 here plus F2. F2 is this is the value. Now in terms of P only, all are, you simplify this, you will get this number of newtons. This is how we will write the free body diagram and try to solve the problems. I hope you will get clarity. You got some clarity here. With this impression, with this experience, now let us will solve some more problems. You will get some other types of problems. You will get a clear picture how to represent solve the problem. See, once again I am discussing the previous problem. What we have to do is first What is the given problem? What is the input data is given? Please note down. Input is W1 is given, W2 is given, friction between A and B is given, friction between B and 4 is given. P is horizontal and 30 degrees. Second case is given. Unknowns are P, normal reactions, tension and thrust. Like that, you have to mention what is input, what is output. Then what is the force system, what are the free body diagram. Then simply writing horizontal vertical equations or sometimes moments. This is how this is a 2D problem. That is another limitation what we are using as far as your syllabus is concerned or GATE exam point of view. Mostly will discuss get the 2D, 2-dimensional. Because 3-dimensional it will take time. From a competitive exam point of view, if it is a third direction, some of the force in Z direction 0. That's how you have to add. Same analogy is valid in 3 dimensions. With this, now let us go to the second problem. Here, similar we have already done. Now I am giving a numerical value. Note down this problem. A block weighing 500 newtons just starts moving down a rough inclined plane when supported by a force of 200 newtons acting parallel to the plane in upward direction. The same block is on the wedge of moving up the plane. It is not down the plane, up the plane. When pulled by a force, this is the second case. First case is applied 200 newtons in upward direction. The same block is on the wedge of moving up the plane. When pulled by a force of 300 newtons acting parallel to the plane. Find the inclination of the plane. Eta is unknown. Coefficient of friction between the inclined plane and the block. What is the amount of friction? That is how we have to represent the input data. Now, input data is, now let us see. First input data. Input data is the weight of the block is given 500 newtons. And horizontal force to one case 200 newtons, another case 300 newtons. That is the data. Now we have to determine the inclined plane angle as well as the coefficient of friction. Okay. Now draw the free body diagram. So this is the free body diagram. 500 newtons downwards. 200 newtons. Here free body diagram represented here only. 500. Weight is downwards. This is the normal reaction direction. Weight down. This is the normal reaction. Actually, this is 200 newtons parallel to the plane. And this is the 200 newtons. This is actually downwards, not upwards. This is F1. This is L. Similarly, here weight is correct. Second case, 300 newtons. Both the case, the problem is same. Only the magnitude change. This is not correct. Don't confuse with this. This is the downwards. By mistake, it is given upward. It is downwards. It is also downwards. 300 newtons. And here, when pulled by a force 300 acting parallel, the same block is on the wedge of moving. This is down and this is up. That is the only thing. Oh, this is the force. Up is, this is correct. Down, up the plane. And this is the down the plane. Because this is greater than this. That's why here, if you can once again read this, I missed. Inclined plane when supported by a force of 200 newtons acting plane in upward direction. And pulled by a force of 300 acting on a plane moving up the plane when pulled out by a force. Find the inclination of wedge of moving up the plane. Both are upward direction. There is no down here. That's why this is acting downward, no question of weight is acting downwards. Weight always acting downward, there is no question of upward. In both the cases, it is given upward only. There is no question of downward. So now let us consider this is what is the analogy. Now if you can resolve 15 cos theta is downwards, 15 sin theta is in this direction. In horizontal, this is one force and this is another force, which we are considering, and try to solve the problem. Actually here, the weight downwards means W downward direction. If you can resolve downwards, W cos theta, W sin theta. W sin theta is in this direction. Okay, this is the left force, so this is actually not correct. We assume as downwards. In that case, if you draw an arrow downwards, like along the same line of action, this is W1 cos the sin theta, and this is W1 cos theta. So that's why horizontal force are this and this, and F1. F1 plus 200 minus W sin theta. This is the equation. Minus, if you move left hand side, minus. F1 is equal to mu times N1 or N. N is the reactive force. That's why F is equal to mu times N. N is 500 downwards cos theta. N is equal to both downward, there is a perpendicular plane. N is equal to W cos theta. This is what is the W cos theta. Mu N, that is 200 plus F1 is equal to 500 sin theta, and in this case N is equal to 500 cos theta, vertical force along the perpendicular plane. N, and actually this is not, arrow is mistake here, arrow making it downward. See, like that. Sometimes if you do a small mistake, the entire problem will be wrong. So now let us go to the second case. Here it is correct representation. Like here also, please, it is not correct. Assume that it is downwards, not upwards. See now here F2, frictional force, direction. Now if you can find out that phi theta making an angle theta, 300 newtons, F2 and N. Now we can consider the vertical forces, this vertical force and horizontal force. This belongs to here. N1 is equal to 500 cos theta. This is downwards. N1 is equal to 500 cos theta. Okay. Now let us come to here. In this case, starts moving case F1 is equal to, because here this particular one mu times N, F2, N is equal to 500 cos theta is equal to N, and 300 is equal to F2, and 500 sin theta. 500 sin theta plus 500 sin theta is in this direction, plus F2 is in this direction, is equal to 300. Now if you can solve this equation and this equation, we will get the values of theta and mu. We got two unknowns, theta and mu, that can be determined from these two equations. So this is how generally we will try to analyze the system. Now let us go to the third case. Note down the problem, third problem. Block A is kept on top of block B. The coefficient of static friction between A and B is 0.6. And between B and ground is 0.5. Also coefficient of kinetic friction, one is static and another is kinetic. Friction between A and B is 0.4. Sometimes the data will be confused like this. Here both the static is given, dynamic is given. Kinetic friction. What value you are going to use? You will test it. That type of that means whatever the data is given, don't think that all data can be used in the problem. That's what you want to analyze. Sometimes this is one of the question coming in the competitive examination. If a force of 60 Newton is applied on a block B, 60 Newtons, Find the acceleration of both the blocks. If mass of the block A is 5 kgs and block B is 10 kg. Mass of the block A is 5 kg and block B is 10 kg. 5 kg means 1 kg force 9.81 newtons. That is 10, approximately 10. That's why 50 and 100, approximately like this. Block B is 10 kg, block A is 5 kg. See, let us consider both the blocks are moving in the same direction. Consider the system. Now here what we will write, this is the free body diagram. F is acting here and F1 is acting here. And 60 newtons horizontal. Because this block B is moving towards right, the frictional force is acting towards left. Normal reaction between these two, N1, N1. N1 upwards, N1 downwards. Here it is N2. Rn. This is how the free body diagram. Now the horizontal equation. Only body is moving in this direction. There is no motion in this direction. That's why it is static only. N1 is equal to, normal reaction is equal to weight. Then N is equal to 100. There is no dynamics in this perpendicular. Only dynamic equation coming in this. That is mass into acceleration is equal to sum of the force in that direction. What is the sum of the forces? 60 minus F1. 60 as for block B is concerned. Our block A is concerned, moving in this direction. Mass into acceleration, 50 into A. Like that we can, 50 into A is equal to F. Okay, here in that way we can, if suppose this friction is not there, neglected, sum of the forces, 60, if let us say it is moving towards right, mass into acceleration, that is 60 into acceleration, is equal to force into this. This is how we will try to represent the equation. Now let us come to the next problem. Because I am skipping the dynamics part, only I explain the analogy. Later we will discuss in detail. At this stage I don't want to confuse with the dynamics, only confined to the statics. But when the acceleration, how it is coming, I explain. See, now let us say, suppose this box is, there is a box, now pulled at an angle of 30 degrees above the horizontal. Similar problem we have done previously. Calculate the force and calculate the normal reaction. Here this is the weight acting downwards and this is the force making 30 degrees and the normal reaction F. And when it starts to moving towards right, there is a frictional force acting opposite to that. That is F. This force you have to resolve axial force and FAX and FAY. FA cos theta and FA sin theta. That's why as far as the horizontal forces are concerned, FAX, FF, there are two forces, that's why FAX is equal to FF. This is the equation. FAX is FA cos theta, FA cos theta. This is the value. Therefore, FF is FAX 43 Newton, approximated 43.3 becomes 40. Then here, vertical perpendicular direction, Fn and Mg and this component is also perpendicular, that is vertical. Fa cos theta, Fa sin theta. Here Fay, Mg is downwards, positive, and Fay is upwards, Fn is the normal reaction is upwards. See, this is how generally we try to represent. Or in other words, Fn plus Fay is equal to Mg. Fn plus Fay or upward positive Fn plus Fay minus Mg. Fn plus, move all our left hand side, Fn plus Fay minus Mg is equal to 0. That equation can be, this is what is the equation. If you move left hand side, minus Mg. From this unknown is Fn, find out. That is what is the 7th unit roughly approximate. This is approximated. Sometimes even gate exam is sometimes if the answer is like this or answer is like this ABCD, you have to put that with the object. With the conventional, you have to solve like this. See, like this we can solve the number of problems as far as the friction concepts are concerned. Now let us go to the what are the other types of friction we come across. What are the other types of friction application? As for mechanical engineering, mostly we are compared with civil engineering, mechanical engineering we will consider the more times friction. Screws like screw jar, lifting bus or automobile, lifting locomotive when you want to replace a tire. That is the best example. Only I am giving a concept here. What is the friction? Where it is applying, the different application. Because in your syllabus application is also given. That's why I don't want to solve any problems here because these are only concepts only. You try to understand application part. As per this subject is concerned, where we use the subject in your 4 years of journey, I am going to give a thought process here. Spare threaded screws, any type of screws, power screws, screw jacks, so many square threaded threads, acme threads, like the different threads are there. As per ASME standards, as per Indian standards. But the concept is here, one concept what we are calling as a helix angle, will consider the pitch and helix angle, etc. But anyway, these are not important. This is what the helix angle and this is the pitch. These parameters we will try to consider in the analysis. But that is not, we are touching only where we are using. See, now the next one is application of the friction. What are the different single thread or double threaded pitch and lead one start thread or two start thread? That also will be considered. Then it can be considered the same thing, but sometimes what is the equation? Like a plane, this is the surface. You apply all the active forces and reactive force. Weight downwards, reactive force. That angle you have to count and find out what are the values. Okay, this is how generally we try to consider. Same in different conditions. Like this is what is the bench wise. When you are doing a carpentry in first year, we will try to carpentry, fitting and other sections, we will try to apply the jaws. Here also, due to friction only, it is a holding taking place between the two blocks. Any piece can be inserted. These are the friction. Up to this, the block is different. This part is different. This is what is the frictional surface. In between, you can put your block. This is another application. In Y's, this is how the carpentry works. Can be done and analysis by drawing a free body diagram. Analysis can. This is the torque we are applying or a axial force. Torque means, as per right hand thumb rule, this is the direction of moment and this is the direction of the force. The force is acting axial. This is what. This is the reactive force, then here also the pin force x direction, y direction. Rotation is possible, two translations are not possible. Y x. Here x is represented. Like that we try to solve the problem. Anyway, this is the free body diagram. Like bearings. Different parts of the bearings we come across here. General bearings, axial friction may be there, rotating is also there. This slab is sliding. This slab is sliding towards left and right, and this is rotating. Okay, this is what is the general bearing concepts we try to use. Friction in machines. Like this is a pulley. Sometimes if we can consider friction here, there is a concept of friction circle also here we have to consider. Anyway, that part we are, as far as this subject is concerned, we have that much knowledge is not required. When you are discussing a bearings, we will try to use. From dependable system to small, some more concepts will come into the picture. See the analogy here, how when it is rotating, how this point is shifting. Because wear and tear and other things we will consider. See now, friction in machines like general bearings, that's what the analysis. Draw a free body diagram, what are the forces you try to represent. And other types of bearing, like thrust bearings now. Thrust bearings, sanding machines. This is where we can use the concept of the frictions. Same thing, disc friction, the thrust bearing analysis. Friction in disc, again disc friction. Friction in machines, belt friction, where this already we have considered, but without friction we have considered. If we consider the belt friction, then there are tensions are not same, T1, T2. We are considering always same tension. But if the friction is there between these two surfaces, this is not same. This is already you have done even in intermediate. T1 by T2 is equal to e power mu theta. If mu is 0, everything e power anything is 0, T2 is equal to T1. That is what the assumption we are using. Mu is 0 in this case. If mu is there, we try to consider this one. Mu and the angle of contact of this belt, beta. If it is 180, 180. Like that you have to monitor. If these two are horizontal, it is 180 degrees. Like that, depend upon the case, it is coming to the picture, the belt friction. See, these are the different mechanical engineering applications where we will come across the, even civil engineering also when we are discussing beams, plates, those all are rough surfaces, bars, trusses, etc. Generally you use it to neglect the friction, but if you are considering a friction at the joints, pin joints, hinge joint, roller joint, that is where the two rubbing surfaces that takes place, you can use the horizontal forces and the vertical forces and try to do the analysis. Okay. Now let us see, today I am giving some assignment. Here, this sheet will be supplied to you, you can go through some objective questions and some conventional questions also. Now let us see here, the two blocks connected by a light flexible cable that passes frictionless pulley. This is the pulley, two blocks. This type of problem already done. Please do exercise at home. The input data is block A weights 500 Newton, block B weight 200 Newtons. The coefficient of static friction between A and the ramp is, this is 0.3. And this angle is given, that 3 by 4. This friction is given, 0.3. This angle is given, that is tan phi is equal to 4, or this value, tan phi. This is inclined plane concept is given. Accordingly, you have to, this is phi and this is also phi. Tan phi is equal to 3 by 4. Okay, this is how generally we can determine two blocks in equilibrium. The case is A, B, C. The two blocks are in equilibrium or not? Are A is moving upwards or A is moving downwards? Depend upon the resultant force. If there is a resultant force, what direction is acting? Is it upwards or downwards? He has asked you to solve the problem. If it is in equilibrium, then the direction whatever you got that is correct. Otherwise, you have to, if it is a negative, that means you have to apply opposite direction. Decide the problem. Now let us see. This is the wedge friction. Here, the wedge inclined. Earlier we have kept a flat surface, but these two are inclined. Earlier this inclined plane you used. Another is like a flat block. Here this is a flat surface. This is the inclined surface. That case we are calling the wedge friction. Here if you can see a wedge A and block B. That is what we are calling as a wedge. Wedge A, block B, subjected load of 1000 newtons Q. Q is external force, 1000 newtons, and a force P. Ignore the weights A and B. A and B weights are negligible. Compare with the force Q, weights A and B are negligible. The coefficient of static friction at surface 1, 2 and 3 are 0.1, 0.1, 0.2, 0.3. That is what they mean. Respectively, the angular wedge A is 30 degrees, this is 30 degrees. What is the maximum value of P so that B does not move? Answer would deemed correct if lies within some range. Clue is given. See now this can be another assignment. I will explain one or two. This is another problem where earlier we have seen this type of arrangement. One is resting on an inclined plane, another is freely falling upwards or downwards. But here the two blocks are there, but two inclinations, 30 degrees, 45 degrees, A and B. The tension in the applied downward, it is moving downwards, means here the frictional force is acting upwards. Here it starts to move in this direction, frictional force is acting opposite to this, and try to analyze. So like this we can, here you can see the three flat blocks are on an inclined plane only. This is an inclined plane, 30 degrees. Between these 13 and 15 kg weight rough surfaces, 0.3. And between the 50 and 40 rough surface, 0.4. I applied a force P. And this is the static, that means this is rest, that case, 0.45. Compare with C. Dynamic, static is more. This is static friction and these two are kinetic or dynamic, starts to moving. And this is how here acceleration is also given. If you want to, the value of G is given. If you want to consider the dynamics, acceleration is also required. See now the solution is also there, but before that this is the NPTEL. If anybody want, you can go through. All answers are given. This problem, similar problem is already solved. Now let us see this problem. Similar, this type of problem you have not done. Previously, once again, go to the sketch. This one. A wedge A and block B are subjected to a load of 1000 newtons and a force P, unknown force. Ignore weights A and B, no weights. The coefficient of friction is 0.1, 0.2, 0.3, 0.1 between these two, 0.2 and 0.3. This is known and this is unknown. The weights are neglected. Compare with the force of P and Q, external forces. The gravity force are neglected. This is 30 degrees. What is the maximum value of P? So that B does not move. You know that is the problem which we will try to solve. This is what is the problem. For minimum value of P, consider the block B tends to move downwards to apply a minimum force downward, and the wedge is, when it is moving downward, it has to move towards right. That is the tendency. When it is moving downwards, it starts to moving towards right, frictional force is opposite. Obviously, with respect to this, the frictional force is equivalent opposite forces. That is what the analogy you have to apply. In the vertical surface, when it is moving downwards, the frictional force is acting upwards, and this is the normal reaction. This is N2 and this is F2. This is N3 and this is F3. The third point and this is second point. Now this angle of inclination is 30 degrees. This is this angle. 30 degrees is given. That means F2 cos theta horizontal, F2 sin theta vertical. Here N2 also with respect to making, because for this line, this angle is 30 degrees. Okay. Similarly, draw one line here. This is 30 degrees. Obviously, if I draw a vertical line, here also determine what is the angle. Now resolve N2 cos theta and sin theta. That means now upward forces, downward forces. 1000 upward force is 1000 plus F2, because this is the angle. This is angle 30 degrees. F2 cos theta is horizontal. You see, this is 30, this is 30. F2 cos theta and F2 sin theta. F2 cos theta is vertical, the horizontal, F2 sin theta is vertical. Similarly, N2 you resolve. Okay. Now in this case, vertical force is F3 and F2 sin theta. F2 is mu times N2 sin theta. Mu times N2 sin theta. F3 is N2, F3 is here. This is the vertical, Fx and Fy. You have to consider the equation. F2 cos 30 horizontal force. F2 cos 30 plus N3 plus N2 cos 60. Because this is the angle we have to consider with respect to horizontal, with respect to vertical, any angle. Consider this you resolve N2 cos sin 60 and vertical N2, because this is 30 and N2 cos 30. N2 sin 30, this is how the N3 minus N2 cos 60, F2 cos 30 at impending. See here you don't confuse. With respect to this is horizontal, this is 30, this is also 30. For this is the perpendicular. For this is the perpendicular. That's why if this is 30, this is also 30. Now horizontal component is N2 sin 30. Okay, like that you have tried to solve the, this is N2 cos 30, N2 sin 30, and resolve the forces along the plane or perpendicular plane, or N3 you can resolve. See that like that you have to find out the horizontal forces and vertical forces, find out the relation between N3 and N2, because both are unknowns here. F3 is equal to mu times N3 and F2 is equal to mu times N2. So now let us go to that is block A. The block A is concerned, this is N2, again the angle between this is F2 cos theta 30 and this is F2 sin 30 along the plane and perpendicular plane. For this is the perpendicular. For this, if you draw a perpendicular line, this is 30. That means along vertical N2 cos theta, along horizontal N2 sin 30. Okay. So this is how we will try to analyze the equation. Here I have written all the N3 is equal to 0.33 N2, that you can substitute wherever is required. F3 is equal to 0.3 and F2 is equal to N3 times and N2 times, and write the vertical equation. Vertical equation is, this is F2 sin theta, F2 sin theta, N2, this is vertical. Like that we have to find the N2 component, then N1 and solve the problem. Okay. Similarly, but this is the case, not block A, block B, this equation. This is the block B, this is Fx and this is Fy. Fx is n3. This is one component. This is one component. That's all. Y is 1, 2. This is one component. And that means with respect to y, you will get 3 components. With respect to x, we will get with respect to y 1, 2, 3, 4 components. With respect to x 1, 2, 3. N2 F2 cos 60 and N2 component F2 component. See N3, N2, F2 component. Depend upon the cos and line whatever. If Fy is 0, 4 components. 1, 2, this component, this. See, that is what is the 4 components. P. Now let us come to the block here. This is the block here, equation. Fy n1 component, this component and this component. See the n1, because this is theta. For this is the perpendicular. For this is the perpendicular. This is the angle theta. Okay. Like this, if you can resolve the forces, this is F2 cos theta horizontal, sin theta vertical. N2 also you can resolve. This is what the value you can consider. From that Ny is N2, then Fx for block A is, this is one component, this is the second component, this is the third and fourth. 4 components are coming to the picture. See, these are the 4 components. From this, find out the value of P. That is the minimum force which we have to apply. Similarly, the last problem, one more problem we'll try to solve here. This problem. 2 blocks resting on A and B. It is a frictionless, the tension in the string. This is the problem. 2 blocks A and B connected by a flexible cord that passes over a frictional pulley. T is a tension exerted on box B, and box A weight 400 newtons, box B weight 900 newtons. The coefficient of static kinetic friction between the bodies and the planes 0.5 and 0.2 in the 2 surfaces. What is the value of T when B starts slipping? Okay, that is what the question. The 2 frictions are given, angles are given, and this is the tension T, force applied. And now if we can see this problem. This is what? For block A, this is a free body diagram. This is a free body diagram. Weight acting downward 600. If this is 45 degrees, this is also 45. Because for this plane it is perpendicular. For this line it is perpendicular. If the angle between these two is 40, these two is also 45. Now because it starts moving downwards, it is moving upward, the frictional force is acting opposite, T1. And 600 is the one force, Na. That is frictional force, normal reaction. Now what is the equation? Let us consider this is a free body diagram, horizontal forces, vertical forces. Okay, along X, along Y, along the plane and perpendicular plane. T1 plus, only T1 is in this direction, F is opposite minus 600, this is cos 45 and this is sin 45. 600 sin 45 is horizontal. That is T1 minus Fa minus 600 sin 45. This is what is the one equation in X direction. This is X direction. T1 minus Fa 600 sin 45. The vertical is 600 cos 45 is equal to Na. 600 cos 45 is, that is upward positive Na, downward negative 600 cos 40. From this Na can be determined, the T1 can be determined. Now go to the block B. Similarly, block B, 900 force, this is the tension in the string. This is the force applied. This is the NB because it is moving downwards, frictional force acting upwards. 900. This angle is 30 degrees. Line perpendicular to this, line perpendicular to this, that angle is also called 30 degrees. See, that is what is the 30 degrees. Now resolve the forces. Fy first. vertical upward force and 900 cos 30. 900 cos 30 vertical upward and this is downward, one equation. Horizontal force is concerned 1, 2, 3 and 900 sin 60. 900 sin 60, this tension is in one direction, these two are in opposite direction. That's why T plus 900 sin 30, 900 sin 30, T plus 900 sin 30, these two are in one direction. These two are opposite, T1 minus FB. FB is equal to mu B times NB. That's what mu B times NB. NB I already got the value. See, from this T is an unknown, find out. See, this is how you can solve any type of problems. See, today we have concentrated mainly what is the friction, with friction, how to consider the problem for different force systems, what are the types of frictions, what are the laws of friction, where we apply this friction, what is the application for mechanical engineering problems and civil engineering problems. These concepts we have discussed today. I hope you got some clarity, but once again I am requesting dear students, here what is the three simple principles, what is the input data given in the problem, represent the free body diagram correctly, then apply horizontal vertical. That is there no question of doing mistakes at that stage. Only the mistakes are happening at the time of representation of free body diagrams. That is very, very important as far as the representation of free body diagrams and angle representation. And regarding resolving forces, your choice. And positive, negative also your choice, but that problem throughout you have to follow the same convention. That is what is the analogy you have to apply. See, today we have concentrated these things and 2 more classes. Tomorrow and day after tomorrow we will touch upon structures, internal force in structures like trusses, frames, bars, etc. And how to, one more principle of virtual work. How to solve the static problems by applying the principle of virtual work. And the center of gravity, center of mass. These are the topics which are left as from the GATE syllabus point of view. So we will try to discuss these things in the another 2 classes. Okay. Tomorrow we will discuss internal stresses in structures, the trusses and frames and other things. See, with this, we will close today's class. Thank you very much for your patience hearing. Best of luck to you. Thank you very much.